good morning, viewers. Welcome back to the session. I'm Dr. C. Raghavendra, Associate Professor, Institute of Aeronautical Engineering College, Hyderabad. Today we will discuss about network models. Okay, so network models is a very important topic in computer networks. So the basic things we are so many things we are going to learn here in this particular session. So especially today we are going to discuss about TCP/IP in network models. We are going to discuss about the TCP/IP in particular. So here a lot of things that were what are the different layers in TCP/IP. Okay, what are the protocols in each and every layer. Okay, what are the purpose of those protocols, why we are using those protocols in that particular layer. So all these things we are going to discuss here, and by the end the student can able to understand clearly what is the main purpose of TCP/IP, what are the various protocols and port numbers. Okay, all these things I can clearly understand. Let's start. Network models broadly have two types. That's one is TCP/IP and another one is ISO/OSI. Okay, so TCP/IP stands for Transmission Control Protocol, Internet Protocol. Transmission Control Protocol, Internet Protocol. And ISO/OSI. ISO generally everybody knows that International Standard Organization, and OSI is a Open System Interconnection. Okay, so we will discuss today TCP/IP, right? And this is a TCP/IP protocol shoot. So here, if you observe this figure, so whereas here there are four layers, so there's a 1, 2, 3, and 4, right? So here each and every layer have a unique set of protocols or exist, and the majorly what are the important protocols generally using in this particular layer, that is it's going to be displayed in this figure. So the layer one, and one thing you need to remember, it's a bottom up approach. That means so bottom layer we can start the first layer, and then next will be the second, third, and fourth, like this. And whereas here, so the first layer we can call it as a link layer. The first layer we can call it as link layer, or in some other textbooks or some other in the web. Okay, so we'll find different names like network access layer, or some other, like say that a physical and data link layer. Okay, anything you can say that, everything is correct. So generally we pronounce it's a link layer. It's the first layer in the TCP/IP protocol sheet, and the second important layer is network layer, and third is transport layer, and fourth one is application layer. Right, now we will see what are the different protocols we will use in each and every layer. Okay, in the first layer is called link layer. So in the link layer, it consists of ARPANET, SATNET, packet radio, and LAN. Okay, these things we are going to use in this particular link layer. Okay, so we cannot say that this is protocols exactly here in the link layer. So why we are not applying any protocols in this layer, I will discuss with you. So in the next second layer called network layer, so which has a ICMP, IGMP. These are all protocols. From second layer onwards, all are protocols. ICMP, IGMP, okay, IP, ARP, or ARP, right? And next, third is a transport layer. So whereas here it's a TCP, UDP. There are two things only, TCP and UDP protocol. And in the application layer, there is one is Telnet, FTP, SMTP, and DNS. Okay, so these are the protocols we are using in this TCP/IP protocol shoot. Okay, so we will discuss each and every protocol and everything in TCP/IP in this session. The first one is called link layer. So in the link layer here, the TCP/IP doesn't define any specific protocol, the protocol defined by the corresponding software, right? So here what happened means, in the link layer, so it is a combination of physical layer and data link layer. See, generally this is a bottom layer. Okay, in the bottom layer, everything what it is there means so we are discussing about mainly communication in the across the world, maybe some devices using the communication devices. So when we are going to use the communication devices or cables, all the things, so here protocols are not come in this particular layer exactly. So that's why here how the communication is going to be established in the network, that is a important role in this link layer. So how we are going to be connected the devices or systems. Okay, so that is a reason. So here we can identify so some ARPANET. Okay, so in the last class, earlier classes, we already discussed about the ARPANET. What is ARPANET? Anyhow, once again we will see very briefly. And so again, what is SATnet, packet radio, LAN? So all these things are just for the sake of how we are going to communicating or connecting the systems from one particular place to another particular place. How we are going to establish a network. So that is completely based related to this particular link layer. We'll see each and every one. So first one is the ARPANET. So we already know that ARPANET stands for Advanced Research Project Agency Network. Okay, so it's not a software; it's a network, right? And a world first packet switching software and core software came to compose the global internet, isn't it? So first this is started for initially, so they are going to, it's a government project, this is actually. So they are going to communicate with all the government bodies, so through the um, network. Okay, so I mean they are just going to establish a network, and they are going to transmit the messages or files, whatever important. So those things are going to be done, and this is the first switching software. So what is switching? Okay, so these things we have another important and interesting topic. So in the later classes we will discuss about this switching concept. We just keep it in mind. What is here? This is a first packet switching software, right? And this is a core software come to compose the global internet. And Department of Defense introduced this system, so it is called D-ARPANET, isn't it? D stands for Defense, right? And ARPANET is nothing but Advanced Research Project Agency Network, right? And the next one is SATnet. So in this particular TCP/IP, the link layer discuss about what are the various ways to connect the systems across the world, isn't it? Across the world or across the region, whatever. Okay, so how they are going to connect. So those things we are going to be highlighted here in this particular link layer. Okay, so in this one is ARPANET, that is just now we have discussed, and the next one is the SATnet. Okay, SATnet, also known as Atlantic Packet Satellite Network, and was early satellite network, we can call it as, and that formed as an initial segment of the internet, right? We can say that SATnet is nothing but a satellite network, and actually we can call it as Atlantic Packet Satellite Network. And it was implemented by BBN Technologies under the direction of the Advanced Research Project Agency. Again, see this again upon it came here. Okay, this is a similar one. Okay, Advanced Research Project Agency. Under this guidelines, this BBN Technologies has introduced this SATnet concept, and this had an origin in Larry Roberts in 1970 proposal for a link between the ARPANET and the National Physical Laboratory Network. I mean, exactly where in the year of 1970, the Larry Roberts are going to start at this one. Where exactly started means in the National Physical Laboratory Network. They itself started this one, and successfully it has succeeded this project and implemented. And the next one is packet radio. Packet radio is one of the technique we are using for communication in from across the world through the internet. And this packet radio is a digital radio communication. So it is a communication mode used to send packets of data. Okay. So what is packets? What is data? So we know data. Data is nothing but whatever the we are going to write, or whatever the thing we are planning to send something. Maybe a data, maybe a image data, or a text data, audio data, video data, anything it may be. It's going to be converted, and those things will be the packets. What is packet here means? A packet is nothing but a set of bits. Okay, See, assume that normally generally bits are going to be like 100, isn't it? So whatever the data we are sending, that means so initially we are much aware of English, no? So we are going to type in English some letter or something else, and we are just going to transmit the letter to the some X person, okay? And how it is going to be transmitted means, so whatever we have written, that the system cannot understand. Why? Because this system is not know what is English or Telugu, Hindi. It doesn't know anything, isn't it? They know only binary language. What is binary language means? It comes only 0 and 1. Okay, that means, so whatever we are going to tell, okay, whatever we are going to plan to transfer the data, those all the things are going to be converted into the uh, zeros and ones only, isn't it? So that's the reason. So everything will be represented in the ones and zeros in the computer, and these communication devices also, they can understand only ones and zeros, and so whatever the data we plan to transmit, those things are going to be make it as a packet. That means we can say that the words, sentences, isn't it? We understand the words and sentences, so how it will be look like and what is the meaning of those things, but the computer doesn't. So that's the reason. So how we are going to transmit the data means, so in the form of packets, that means some group of bits are going to be formed as a packet. Okay, assume that maybe 10 bits or 20 bits. So based on some criteria, so there, so based on that, the packet is going to be fulfilled with the data, uh, and is going to be, that packets are going to be transmitted across the over the internet, and it reaches to the recipient system, right? So packet radio uses packet switching to transmit the datagrams. Okay. Packet radio uses the packet switching. Okay, so we have two types of switching. So in the next session, we are going to discuss about those switching concepts. Where itself we are going to discuss about two things, that is a circuit switching and packet switching. So we just try to keep in mind the terminology packet switching. Okay, and in the next session we will discuss about what is packet switching, what is circuit switching, what is the difference. Okay, we'll discuss clearly. So whereas here the packet radio uses packet switching to transmit the datagrams. So datagram is nothing but it's not new word. It's just like a data packets only. Okay, the terminology is going to be a little bit different. It's a datagram, but it is also a data packet. It's also both the same, right? And packet radio can be used to transmit the data long distance. Packet radio. I mean, why we are using packet radio? Why can't we use a satnet? Why can't we use the ARPANET? Means, so the intention of a packet radio is, so when we use the packet radio concept for the network, that means a communication, so we can able to transmit the data over long distances, okay, across the world. Suppose you are here and your friend is a recipient person is in very far away from here. So in such a long distances, packet radio is useful, because we it's a basic things we know well. So the radio signals strength and radio signals, how far it is going to be, how fast it is going to be transmitted in the air. That's the basic things we already know that, isn't it? So the next immediate layer called second layer, network layer, right? In the network layer, we have some set of protocols. Okay, so what are the protocols we have seen in the picture? So the first one is called ICMP. ICMP stands for Internet Control Message Protocol. Internet Control Message Protocol. So please try to remember the protocol names and the acronyms of the shortcuts, isn't it? Okay, so you don't think always don't try to remember only ICMP. You just try to remember what is ICMP. ICMP stands for Internet Control Message Protocol. So generally, this particular ICMP protocol used for sending a query and error responding messages. That means, so if any user, so I already told you that what is user, who is user. User is nothing but whoever operating in a system, we can call it as an user. Okay, so if any user sending some sort of queries or error reporting messages, that means they are performing some operations in the system, and if they are not able to perform the operation successfully due to some sort of errors, okay, and those errors are going to be send it to the servers. Okay, so for these error messages are going to be transmitted from source system to the server. Okay, so these can be happen with the help of ICMP. Clear? And next is the IGMP. IGMP stands for Internet Group Message Protocol. Okay, IGMP stands for Internet Control Message Protocol. IGMP stands for Internet Group Message Protocol. And this particular IGMP protocol is used for simultaneous message transmission to group. Right? Simultaneous message transmission to group. That is the purpose we will use this one. So the name itself we can clearly able to understand and easy to remember. It's a group message protocol. So it's a transmission for group. And next important protocol is ARP. ARP stands for Address Resolution Protocol. So this address resolution protocol used to associate IP address and physical address. Okay, this is ARP is used to associate IP address and physical address. Okay, and it is used to find the physical address when it is intended address is needed. That means assume that address resolution protocol having the IP address. Okay, I mean, so one system IP address it knows. So based on the IP address, okay, it is able to identify the physical address. Clear? So this is possible with the address resolution protocol. And this RARP means reverse ARP, reverse address resolution protocol. It is nothing but, so whereas here it having the physical address, and based on this physical address, it can able to identify IP address of the system. Okay, and it allows the post. What is post? Post stands for power on self test. So it allows the post to discover its internet address with discover its internet address, which is only when if it is a physical address is having. That means, so whenever it having a physical address, okay, based on this physical address, it can able to identify this IP address, and this can be possible post. Actually, where we heard this post actually in this means, so when we nowadays it is a bit difficult, but when you operate the older systems, when you desktop systems, so when you switch on the system, what will happen immediately? One blank screen will come where some text will be coming out and going on, and some beep sounds will come over there in the between before going to start getting the blue screen, right? Isn't it? So what happens exactly between getting a Windows screen means, so the system it's going to run the post, that is power on self test. That means so whenever we switch on the power button of the computer, automatically it checks that so whether the first initially whether motherboard is getting working or not properly, whether RAM is working or not properly, whether the connected devices, whether the maybe the monitor, keyboard and printers is there, no? So we have connected to CPU, isn't it? Whether all are in working condition or not, it is going to check all the things. So that is the reason in the black screen there are some text is going to be coming out and going out, and some beep sounds are coming here. The beep sounds also indicates that error codes. Okay, so based on the beep sound we can identify so what is the system problem. Okay, there are some beep codes will be there, so like that is going to be there. So there is a big flow chart will be there. So what are the things are going to be checking in the initial stage, so that is called post. Okay, so here also the same thing is going to be happen here. So where itself the based on the physical address it is going to be identify the IP address of the system. So actually what is IP address? Okay, so IP is a protocol, internet protocol. Here we have two versions, IPv4 and IPv6. Okay, we'll see. See, IPv4 is a 32-bit or we can say that 4 8-bit numbers. Both are same. Okay, 4 8-bit numbers means it is nothing but 4 into 8. It's again 32-bit only. right? So it is a 32-bit number. So this is an example IP address. Okay. So even whenever you want to check your IP address of your system, it's very simple. And every system have a unique IP address. So when you go for a DOS prompt by using you just open this run prompt and then type command, press enter. There you can type IP config and then press enter. Okay, when you press like this, okay, okay, IP config. When you type this IP config in the command prompt, so you will get your system IP address, right? And this is one example of IP address. It's 18.26.0.1. So where the first digit, okay, the first octant, we can say that the first one indicates that network address. In the IP address, the first part indicates a network address and the next is a host address, right? And IPv4 is a 32 bit and IPv6 is a 128 bit length. Remember, it's not again after 32 generally how we are going to think as a computer science students. So 32, 8, okay, 0, 2, 4, 8, 32, 64. Again, they plan that okay, IPv4 is 32 bit and IPv6 is a 64 bit. Okay, that is wrong. And IPv6 is a 128 bit address length, right? And it is unique to server, printer, computer, which are able to enable the internet. Which are able to enable the internet. What it mean? Which are enable the internet means so whichever the devices are going to able to communicate. That means communication devices. A communication device may be a server, computer, mobile, okay, a pager or some others. Okay, anything we can which are able to enable the internet. All those having a unique IP addresses. The next important layer is transport layer. This is third layer, right? This transport layer having two protocols, namely TCP, UDP. We have only two protocols called TCP and UDP. What is TCP? What is UDP? We'll see, right? A TCP stands for Transmission Control Protocol, specified in 1974. Here, it was specified in 1974, and this is a connection oriented. Okay, TCP is a connection oriented, and this is a session is established before exchanging the data. That means, so this is a connection oriented. That means whenever a system want to communicate with another system which is far away from the base source system. That means, so before going to start the communication, first of all the session have to establish from source and destination system. Okay, so the best example we can say that LAN phone, right? See, if I want to call to LAN phone, okay, first of all the recipient LAN phone and our LAN phone both must be a connection must be established because it's a wide one. No, LAN phone is a wide connection. A wide connection must be established earlier before going to call, isn't it? So that is the ring here. This is a connection oriented and session must be established before exchanging the data. And this is a reliable delivery. That means we already know that what is reliable delivery. So without any modifications or any disruptions, the data, whatever the sender want to send the data, the same data has to receive by the receiver. Okay, and here this reliable data can be achieved with the help of sequence number and acknowledgements. That means, so I already told you that just before. So the data will be transferred from one place to another place in the form of packets, isn't it? So for each and every packet is going to be assigned a sequence number. Okay, so the packet 1, packet 2, packet 3, because we are going to send some bunch of data, like assume that some 1,000 pages of text is there, the document. We cannot able to store 1,000 pages of document in one particular packet, isn't it? A packet can able to store a small piece of data, small piece of bits only can able to handle. So when we are going to send 1,000 pages of data, we require a huge amount of packets are required. So for each and every packet, we are going to assign a sequence number. First packet one sequence number, second packet second sequence number, like this we are going to be sent. So after receiver receive those packets, they are going to send an acknowledgement for each and every packet. Okay, now I received packet 1, I received packet 2. If packet 3 is not received and packet 4 received, is going to send an acknowledgement that so I received packet 4. So packet 3 is nothing but it's not received. Easy to identify where exactly which packet is not received, right? Here information will be divided into small units called segments. Okay, here in this particular transport layer, earlier what I said, so data will be in the form of bits. Bits is nothing but ones and zeros. Again I said that packets is nothing but some group of bits. But in this particular transport layer, this data can be represented in the form of segments, not like bits or packets. Okay, that means a group of packets, we can call it as a one segment. Okay, some group of bits or call it as packet, and group of packets we can make it as a one segment, right? And this is very important, and everybody have to please remember the port numbers. Okay, TCP port numbers and that particular port number what it is going to describe, that is very important. So the port number 20 describes a FTP data channel. FTP stands for file transmission protocol. Okay, we will discuss what is FTP, what is the purpose of FTP in the next slide. Okay, FTP data channel, and 21 for FTP control channel. So remember 20 is for data and 21 is for FTP control channel, and 23 port number 23 for telnet, terminal network. Okay, and 25 for email, and 80 for HTTP. HTTP stands for Hyper Transfer Protocol. Okay, we will discuss all these. Telnet is already discussed now, so we will email already. Everybody knows that what is email, isn't it? And HTTP is there. So in the fourth next layer, application layer, we can see this. What is HTTP, and what is the purpose, right? And please remember this port numbers: 20 for FTP data channel, and 21 for FTP control, and 23 for telnet, 25 for email, and 80 for HTTP. Right? Now we will see UDP. So TCP is over just now in the transport layer. Now we will discuss the UDP. UDP stands for User Datagram Protocol. UDP stands for User Datagram Protocol, which is specified in the year of 1980. Right? And it provides a connectionless service. And TCP is connection oriented service, and UDP is connectionless service. Okay, and do not support sequence of flow control, isn't it? So here in the TCP, what I said, so there is a sequence number acknowledgement is there. So based on the sequence number, it is going to be transmitted, and the recipient side also they are getting based on the sequence number, they are going to identify which is not received exactly, isn't it? But whereas in this particular UDP, so it does not support sequence number and flow control. That means so it is going to identify their own path and it reaches to the destination, and whether it reaches exactly or not, that is a secondary, but it is not going to flow in the same way. Okay, see always, for example, the best example for TCP and UDP for just for the sake of remembrance. So, for example, you are a student of one particular institute, and you are coming from your place to college through the college transportation. Okay, that is bus, college bus. So then there is a standard route. Every day the bus is coming in from the same route. It's coming to the coming and reaches to the college. And again, while leaving the college, again it moves to the same route only. That is called TCP. Okay, and UDP is nothing but a user datagram protocol. Here it's a connectionless, and it doesn't follow the sequence and flow control, right? So what happened here? So it's nothing but your own transportation. So assume that you have a bike or car is there, and no need to follow the same route every day. Maybe due to some traffic, or if road is not good, okay, what you can do, so you can prefer some other ways, okay, like this. So there is no mandatory for the data or the packets are going to be moved from the same direction. So it can choose their own direction, and ultimately the destination is same, clear, and used in client server application, okay. And this UDP used in client server applications we are used. And it is going to, UDP is also used for transmitting the speech or video, okay. That means not only the text, even if they want to transmit the speech or video also, we can able to transmit with the help of UDP protocol. The next important is SCTP protocol. SCTP means Stream Control Transmission Protocol. Stream Control Transmission Protocol. It is a transport layer protocol that combines the good features of TCP and UDP. Please, it's very important. So it just uh, this is also actually in the figure, okay. I have mentioned only TCP and UDP, okay. Actually majorly we are if you observe any textbooks, or majorly we can identify only TCP and UDP in the transport layer, we can identify these protocols, but if you go in depth, there is another protocol in TCP, in the transport layer, that is called SCTP, Stream Control Transmission Protocol. So this protocol is a combination of good features of both TCP and UDP, okay, and it supports new applications such as IP telephony. In that for such new applications, we are using this SCTP protocols. And the next and last layer, that is the fourth layer, is application layer. Here we have some set of protocols. So the first one is called a telnet. So telnet stands for terminal network. A virtual terminal protocol allows a user or one mission to log on to a distinct mission. Here telnet means telnet. So that's why I highlighted here like this. Okay, it's a terminal network, and this is a virtual terminal protocol which allows the user. Okay, so this is a terminal protocol. That means it is a one system. This protocol is available. That what it is going to do means it just this is a protocol which will be available in one particular system, is connected to internet, which allows the user or a mission. It allows the user a mission to log on to a distinct mission. It log on to a distinct mission. And next is the FTP. FTP stands for File Transfer Protocol, and this was introduced in the year of 1973, and it is used to transmit the information from one mission to another mission. Okay, so File Transfer Protocol. Okay, so that means if you want to transfer a file from one system to another system, we will use FTP protocol, right? So this is introduced in the year of 1973. Very simple, easy to remember, right? Our next important protocol is SMTP. SMTP stands for Simple Mail Transfer Protocol. The name itself, we can clearly understand the concept of what is the purpose of SMTP. It's a Simple Mail Transfer Protocol. The applications we are using this one is email system. In the email system, we use SMTP protocol. Just because if you want to type a mail or something, you are going to type a text and you want to send it to your friend or some organization, with the help of SMTP protocol, is it possible to? It is possible to transfer your data from your system to the destinations. And next is the DNS. So this is very important. DNS stands for Domain Name System, which is introduced in the year of 1984. And the function of DNS stands for Domain Name System. The function of DNS is to translate the domain name into IP addresses. Okay, translate the domain names. What is domain name? .com. Okay, .in. So ac.in. Okay, .gov. Okay, so what are these? All these things. These are called, we can say, the domains. Okay, you can say that google.com, okay, gmail.com, yahoo.co.in, okay. So all are these .com, .go, okay. So these are all called, we can say that, domains, okay. So all these domain names into IP addresses. Translate the domain names into IP addresses, which computer can understand. Clear? The computer cannot understand .gov, .in, .us, okay, .edu. These things the computer don't understand. The computer understand only the IP addresses, binary digits, isn't it? So even IP addresses also, it will be converted again into zeros and ones. But just for the sake of easy to understand and easy to access, it will be converted into IP addresses. And because IP addresses is the only one to uniquely identify that particular device across the network. Across the network, in the sense, across the world, we have so many n number of networks, and each and every network have a n number of devices are connected. Each and every device is going to be identified with the help of IP addresses only, right? And this is an example. So we'll see that. It is used to map the names on one of the network address, and it is a numerical structure. And the best example for this one is postal system. So in postal system, so if you write a letter and and you are going to post it through the postal method, okay, what you are going to do after writing a letter, in the space we are specified here, there itself we can write the to address, isn't it? To address and from address. From address indicates that your address, right? Sender address. And to address describes the recipient address. So generally what we are going to do in the recipient address means, so what we are going to write, name and clear, the house number and street, isn't it? Again, place, okay, and state, okay, here district, okay, and finally write the pin code, isn't it? That clearly we need to specify, okay. Then only the letter which are trying to post, those will be delivered exactly to the where exactly we planned, okay. That particular recipient will receive by this letter, isn't it? In similar way, in DNS also, it look like the same postal manner. So how means, see, if you just observe this figure, here we have various domains, so .es, .com, .gov, .edu, .org. These are the various domains. Under these various domains, we have again so many subdomains are there, right? Here, MDZ house in the .com, okay, some different subdomains are there, okay. For example, if I want to just Maria is there, okay. So if Maria want to send a request to the government body, okay, then how the address look like? So Maria dot cs dot colorado dot edu. Now this is a Maria address, okay. Now this Maria is going to send a letter to the dot gov, okay. Like this the address should be, okay. The complete address should be like this, it will come like this, okay. So this is an example here. So the first foremost, we can say that root, generally it should look like a tree model. So where we have a lot of domains like .net, .edu, .com, okay, .gov. These are all the top level domains, we can say that, okay. So again in this .com, we have one subdomain is there, that we can call it as second level domains, okay. Again we have a subdomains for the second level domains. So cluster.example.com, that means cluster is here, okay. So this particular node is called cluster. So the address how look like? Cluster.example.com, and mail is the this node, mail.example.com, and here www is there, okay, and this address is www.example.com. This is a subdomain representation, okay. And the host, what we can say that host is a, that means again in this particular subdomain, again we have a n number of host. Host is nothing but computers. Okay, that means in particular cluster, again we have a n number of hosts. Assume that 100 hosts are there. Okay, in cluster 100 hosts are there. So now here node 1, that is first system, the node 1 dot cluster dot example dot 1. So this is a host address. So like this we are going to be represented. Clear? Thank you so much for watching, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.